Welcome guys, let's continue our discussion on consumer theory, which is the building block of microeconomics. In the last two videos, we have covered some primitive notions and also the types of preference relations that we have in consumer theory. If you didn't watch yet, I will put the link down in the description. You can refer to them as well. So basically in the last two videos, we have talked about primitive notions such as the structure of the overall structure of the consumer theory, consumption set and properties of consumption set, and also about the preference relation, what is preference relation, what is weak preference relation, what is a strong preference relation, and what is indifference preference relation. But in this video, we will have a deep dive on the concepts of axioms of choice, which there are two main categories. The first category, which is completeness, transitivity, and reflexivity, which they are the axiom of rationality. And also we will talk about continuity, local non-satiation, monotonicity, and convexity, which the other axiom of choices, which are needed for the well-behaved preference relation or well-behaved utility function. So now let's go without wasting our time and cover the axioms of choice. So the third part in this video series is the axioms of choice, and the first axioms of choice is completeness. What the completeness says, it says that for any two bundles of goods like X and Y and consumption set of X, either X is at least as good as Y, or Y is at least as good as X, or both. It means that X is at least as good as Y and Y is at least as good as X. So it means we are indifferent between the two bundles. Here, X and Y represent a bundle of goods. And this notation denotes the at least as good as. We use this notation for the preference relation, specifically for the weak preference. So actually, completeness means that for any pair of goods or bundles of goods, a consumer is capable or able of comparing them. Like a consumer has necessary knowledge to evaluate different alternatives and express their preference for one bundle over the other bundle. So in this axiom, it basically says that consumer cannot say I don't know. So it means they have this capability, they have this ability to rank, to prefer one bundle over another one. So if a consumer say I don't know, in this case we will not be able to know the preferred bundle. So again, let's emphasize that consumer cannot say I don't know, otherwise best preferred bundle is not known. So let me provide an example of this completeness. Suppose we have two bundles of fruits, fruit of F1 and fruit of F2. So assume F1 is X and F2 is Y. So there are three types of relationship could be between bundle of X and Y, or F1 and F2. Either a person can weakly prefer X to Y, or the other way around, Y to X, or can be indifference between both. That means for a consumer, either X is at least as good as Y, or Y is at least as good as X, or a consumer can be indifferent between the two bundles. Between F1 and F2, it means they have the same fulfillment, the same desire, the same satisfaction and happiness for a consumer. So this is the axiom of completeness. So now, let's see the second one. What is the second one? The second assumption is transitivity. This axiom says for any three alternatives or three bundles such as X, Y, and Z in consumption set of X, if X is at least as good as Y and Y is at least as good as Z, then X is also at least as good as Z. Here again, X, Y, and Z represent bundle of goods, and this notation again represent at least as good as, or weakly perfect. Basically, this axiom states that if a consumer prefers one bundle of goods to a second bundle and prefers the second bundle to a third bundle, then the consumer must also prefer the first bundle to the third bundle. So now let's have another bundle of fruits in our set of choices, which is F1, F2, and F3, or another notation that we use X, Y, and Z. X, Y, and Z. So, if you prefer X to Y, if X is at least as good as Y, then here Y is at least as good as Z, then X is at least as good as Z also. Or in another notation, if F1 is at least as good as F2, and F2 is at least as good as F3, then F1 must be at least as good as F3. So this is the axiom of transitivity. Now, let's see the third axiom. The third axiom is reflexivity. Under reflexivity, it states that any bundle X, such as any bundle X, is always at least as good as itself. Like that is any bundle is at least as good as an identical bundle. For example, F1 is exactly identical to another F1. If you have the two similar identical basket of fruit or bundle of fruit, it means one bundle is at least as good as its identical bundle. Then if F1 is at least as good as F1, or X is at least as good as X, it means we are indifferent between two identical bundles. It's a trivial axiom, but sometimes this axiom can be violated, specifically, occasionally, for the behavior of small children. Because mostly small children, even they rank two exactly identical bundles. If you have two similar apples, if you ask them which one do you like, they will not say I'm like indifference. They will see, if you give one of the apple to them, they will say, no, I don't want this, I want another one. Although they are similar, they are identical. Suppose or assume they are identical, but still they are preferring one to another one, although are identical. But this axiom can be plausible for the behavior of most adults. So let's make a conclusion for the three first axioms of choices. If a preference relation satisfies axiom 1, 2, and 3, is termed rational. So a consumer can be called a rational consumer if he satisfies the axiom of completeness, the axiom of transitivity, and the axiom of reflexivity. These three are the rationality axioms. So now let's cover some other axioms which they are needed in order to have a well-behaved preference relation. So the fourth axiom is continuity. This axiom says that the preference relation on X or in X is continuous if it's preserved under the limit operation. Or in other words, we can say for every converging sequence of pairs of commutative bundles, like a sequence of x to n and y to n start from 0 to infinite, such that x to n is at least as good as y to n for all n, where x is equal to the limit of x to n when n converge to infinity, and y is equal to the limit of y to n when n approach to infinite or converge to infinite. Then x is at least as good as y. X is at least as good as y. Also, there are other ways in order to formulate this axiom. There are two other ways. The second way is, given a bundle Z, for example, given a bundle Z, both the upper contour set, which is y and x, such that y is at least as good as Z, and the lower contour set, y and x, such that Z is at least as good as y, are closed set. Or as a third way, both a strict upper contour set, y and x, such that y is strictly preferred to Z, and the strict lower contour set, y and x, such that Z is strictly preferred to y, are open set. So in the case of second way and third way, also we have continuous preference relation. So now let's say about this one, why do we need these axioms? What it implies? Why it's helpful? It implies that small changes in the quantities of goods in a bundle or in the consumer's income should not result in sudden jump or discontinuities in consumer preferences. In more formal way, this axiom and preference relation means that if two bundles of goods are very close to each other, then the consumer should be indifferent between them or nearly indifferent between them. And in terms of mathematics, we can say this axiom and preference relation is often expressed using the concepts of indifference curve. This is indifference curve, this green line. An indifference curve represents bundles of goods among which a consumer is indifferent. So in this indifference curve, different combination of goods and services or different bundles of goods and services, which is, for example, A, B, C, D, they are indifferent for a consumer. So this axioms implies that these indifference curves are smooth and continuous without sudden jump or gaps. So as you see this indifference curve, there's no jump, there's no break, but it's continuous, starting from this extreme point to this extreme point. There is no jump, there's no break, there's no discontinuity in this indifference curve. So we have a smooth and also continuous preference relation in this consumer behavior or in this indifference curve. So now let's move to another axioms, which is the axiom of monotonicity. First of all, let's talk about the axiom of local non-satiation, which is the axiom of 5 bar. Then we will talk about the monotonicity. Actually, both of them are closely related, so one can be supported for another one. So local non-satiation, which is in short we can only say LNS, a preference relation on X or on consumption set is locally non-satiated if for any X or any bundle of X and consumption set of capital X, and for every epsilon greater than 0, there exists another bundle of Y and X with this relationship. the absolute difference between y and x is less than or equal to epsilon value, such that y is preferred to x or is strictly preferred to x. In another word, we can say that for each x there exists y that is arbitrarily close to x and y is strictly preferred to x. Here, this epsilon represents a small positive change. A small positive change. And this y minus x, with the absolute notation, represent the absolute difference between bundle x and y. The absolute difference between bundle x and y. So, this locally non-satiation or locally non-saturated preference relation states that the consumers always prefer more of a good to less. More of a good to less. It means more is always better than less. Or another way we can say that LNS or local non-satiation preference relation demonstrate that the consumer always prefers bundle that contains slightly more of at least one good, even it's very small. So let's say this example. In this example, bundle X has 2 apples and 3 oranges. And bundle of Y has 2 plus epsilon apples and 3 oranges. In this case, the bundle Y, which has slightly more of apple than bundle X, then bundle Y is strictly preferred to bundle X. Even though this epsilon is too small, for example, 1/5 of an apple. But still, because Y has more of at least one good, which is apple, then bundle X, then Y is strictly preferred to X. So this axioms or LNS rolls out thick and circular indifference curve. Thick and circular indifference curve. Because when we have thick and circular indifference curve, so we may have 2 different points which we have at least one good more. One of good more. For example, let's see this thick indifference curve. In this thick indifference curve, suppose this black dot is the X bundle. Black dot is the X bundle, which we have this much of X1 and this much of X2. Let me use the pen. For example, we have this much of X1 and this much of X2. And if we have thick indifference curve, for example, in this area, in this point, we have the same amount of X2, but we have more of X1. Then this point is strictly preferred to this point because at least we have more of X1, even though we have the similar amount of X2. So this axiom rolls out this thick indifference curve, or also circular indifference curve, because in the circular indifference curve, suppose this is epsilon, this is epsilon, this is y, this is x. If we see, for example, compare this x and y, one of them has more of at least one of goods. One of them has more of at least one of goods. So then when one of them has more of at least one of goods, it means we prefer that bundle to another bundle. So overall, LNS demonstrate that more of goods is always better than less.